Morning, mathematicians, and welcome to our math workshop. As we continue to explore numbers within 100, today I want to teach you that mathematicians will identify 10 more, 10 less, 1 more, and 1 less than a 2-digit number within 100. We have our number grid to help us in case we might need it. So right now we're going to practice finding 1 less and 1 more than a given number. So our number is 17. We can easily find it on our number grid. You see it? So if I was to ask you 1 less, we can go to the number on the left. 1 more is the number to the right. Or we can say 1 less, you count backwards 1, right? And 1 more, we're going to count forward 1. So looking at number 17, 1 less is what? Is 16. 17 again, 1 more will be 18. Excellent. Let's move on. So we have 45. 45, 1 less. 44. 45, 1 more. 46. So let's see. Now we're going to practice finding 10 less and 10 more. So we're going to find a given number, which is 19, right? We can count back 10 spaces to find 10 less, and we can count forward or count up 10 spaces to find 10 more. Or we can just look at the pattern that we're about to see. Here we go. So 19, 10 less will be what? 9. 10 more will be what? 29. So let's take a look. What pattern do we see? We have 9, 19, and 29. What pattern do you see? Can you turn and talk to someone at home? So 10 less is the number that's above the number, and 10 more is the number that is below the number. Okay? So looking at number 64, which is our next number, 10 less will be what? 54. Excellent. And 10 more? 74. Let's see. 88. 10 less? 88. 10 less? 78. 10 more? 98. Very good. Now we're going to follow the video to continue with our lesson. Follow the video and work along.
Right, this is first grade, Module 6, Lesson 5. And in this lesson, students are going to be learning how to identify 10 more, 10 less, 1 more, 1 less, working within 100, so 2-digit numbers. The idea is, this for a lot of teachers and parents, this might seem like so trivial. Why are we doing this? And the real reason is this is a precursor, kind of like a foundational concept, so that students can begin to develop number sense, so that when they begin learning like those standard algorithms for adding numbers, that they can do some of this stuff in their head. That helps with estimation. It just helps with checking their answer in the back end. So this is one of those foundational kinds of lessons that on the day that you're doing this lesson, it might seem like, why am I teaching this? But it really is important in the long run for developing our students into these wonderful little mathematicians. So let's get started. All right, so let's say we're going to begin with a number. Now, I'm going to let you know in advance, I'm going to draw the number 34. All right, so now in that concrete pictorial abstract progression, I'm going to start with the pictorial, and we're going to use quick 10. So we're going to model 34. 1, 2, 10, 20, 30, and then 1, 2, 3, 4. So I just modeled 34. And I'm using the pictorial representation at this point. Now, if you, we're not going to do the abstract. The abstract right now is just saying start with 34 and then add 10 or subtract 10 or add 1 to subtract 1 with just plain old naked numbers. But I'm going to use a pictorial representation. Now, parents and teachers, if your students are struggling with this, maybe you're going to have to step back and go to the concrete representation where students are using actual base 10 blocks or pneumacon shapes. in order to build this number in a concrete fashion. But I'm going to do pictorial for right now. And so the idea is we have 34. And if we wanted to demonstrate what is 10 more than 34, we would just have our students add one more 10. So they need to recognize that these are the 10s, these are the 1s, and that they could say, oh, 10 more than 34, 10 more than 34 is, and we get 44. And they can see that, oh, there it is. And then if we wanted to start with 34 again, so let's start with 34 again. So I'm going to do that right there. Okay, 34 again, 10, 20, 30, 1, 2, 3, 4. And if we wanted to say 10 less, so 10 less than 34 is, so what are we going to do? Well, now instead of adding an extra 10 like we did up here, now I'm going to zoom in and we are going to cross off one of the 10s. And so what are we left with? Well, we're left with 2 10s and 4 1s. So we end up with 24. So 10 less than 34 is 24. Now, parents and teachers, that's the idea, is we're going to be using our pictorial representations, quick 10s, or actual pictures of base 10 blocks to answer these relationship kinds of questions. 10 more, 10 less, 1 more, 1 less. If your students are struggling with pictorial, go to the concrete. We're going to avoid the abstract today. All right, so the directions say solve, and you may draw or cross off, as in using an X, to show your work. So the idea is, it says 10 more than 79. Well, first off, let's verify that this is actually 79. So I see a 10, 20, 30, 40, 50, 60, 70. So I see 7 10s. So that gives me 70. And then I love the fact that they put these in 5 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we do indeed have 7 10s, 9 1s. So we have 79. Now, if we wanted to do 10 more than 79, what would we need to do? Well, we would need to add one more 10. And so I'm going to draw a quick 10. There's my quick 10. So what do we have now? Well, instead of having 7 10s, we now have 8 10s and 9 1s. So we now have 89, 8 10s plus 9. And that's the idea. So if we wanted to just skip down here and say, what is 1 less than 80? So we see that we have 8 10s, and there's our 80. And if we wanted to cross off 1, because it says 1 less, so we're going to cross off 1 little unit, and that gives us, how much? What is that? What does that give us? Well, it gives us 7 10s. Here's our 7 10s right here. And this is our 9 1s, so we end up with 79. Now, parents and teachers, our students are going to want to just jump straight to the answer. And that's cool. And eventually we really do want to get there. But we don't want them to do that at the expense of developing this pictorial understanding, this foundation of what are we doing when we are adding 10 or subtracting 10. We are removing a whole strip if we're subtracting, or we're adding a whole strip if we are adding 10 more. And that's the idea. So we are going to want students to kind of make this super fast, intuitive, but not at the expense of building understanding. So we're going with a little bit more abstract. It says find the mystery numbers. We're going abstract in that we've removed the pictorial, and now we're kind of going into that concrete. And so this says 10 more than 75. Well, first we're going to build 75, and this says we have 7 10s and we have 5 1s. So if we're going to add one more set of 10s, instead of having 7 10s, we're now going to have 8 10s. We're still going to have 5 1s. So our 10 more than 75 becomes 85. Over here, if we're going to have 1 more than 75, well, first we need to build our 75. So there's our 75. So we have 7 10s and 5 1s. And if we need 1 more, 1. So instead of having 5 1s, we're now going to have 6 ones, and the 7 stays the same, so we end up with 76. And that's the idea. And actually, let's do just this, 10 less than 88. So first, let's build 88. So building 88 means we're going to have 8 tens and 8 ones. Now, if it says 10 less, what does that mean? Well, that means instead of having 8 tens, we are going to only have 7 tens because we got 10 less. We're eliminating one of our 10 strips, right? Our quick tens. And then, of course, the 8 stays the same, 8 as in 8 ones, and so we end up with 78. Now, parents and teachers, that's the general idea, is we're thinking of these numbers, this, for example, 75, as 7 tens and 5 ones, and that allows our students to manipulate by adding 10, subtracting 10, adding 1, subtracting 1.